Graphing a function, f of x equals 4x minus 1. We've mentioned that f of x and y are interchangeable. That all this is when we replace f of x with y is going back and forth between the function language and the equation language. So written as a function, this is f of x equals 4x minus 1. Written as an equation, this would be y equals 4x minus 1. Sometimes if it's helpful to just convert to equation language, we can do that and just resort to our old tricks. This is now an equation in the form y equals mx plus b. And therefore my slope m is equal to 4, which I'm going to write as positive 4 over 1. So that's a rise of 4 and a run of 1. And my y-intercept is the point with coordinates 0, negative 1. So starting at negative 1 on my grid, I'm going to use my run of 1 and rise of 4 to get another point, and a run of 1 and a rise of 4 again to get another point, and then draw the line that passes through those points. So really, graphing a function is no different from graphing an equation. We just want to think of that f of x as a y, maybe change it to a y if it makes us more comfortable, rely on all our old graphing techniques. Going on next to g of x equals the absolute value of x minus 1, we're going to start this the same way. I'm going to replace my g of x with y to change this to y equals absolute value of x minus 1. And then I'm going to think about the graphing techniques that we saw when we were first starting to talk about graphing nonlinear equations. Note this is a nonlinear equation. We know that because it has an absolute value, and the linear equations are the ones that just have an x and a y not taken to any powers and not with any other operators like square root or absolute value in them. So they're equations that can be put in the form y equals mx plus b. This one cannot because of the absolute value, and therefore we need to plot several points. So I'll make up a table here, and I'm going to use x values from negative 3 up to positive 3. If we recall from when we were graphing nonlinear equations, this should come out to be a V shape because it's an absolute value function. But even if we don't really know for sure that it should be a V shape, by the time we've plotted several points, we should be able to tell. So filling in these values, I'm going to start with the absolute value of negative 3 minus 1, which is the absolute value of negative 4. And so this value is going to equal positive 4. I'm going to go ahead and do this computation for all of the remaining x values. So here I have filled in all of my y values that I'm going to graph. And I'm going to notice here that it looks like this 1, 0 is the point where it's going to turn around that vertex of the V, because I can tell my y values were decreasing until they got to 0, and then they started increasing again. We have to be really careful when evaluating these absolute value expressions to make sure we are thinking about every computation and not just going with the pattern that occurs when it's linear. So negative 3, 4, negative 2, 3, negative 1, 2, 0, 1, 1, 0, and then it turns back around, 2, 1, 3, 2. This is definitely enough that we can get a pretty good idea of what the shape is overall. So I'll go ahead and fill in the two pieces here of my V.